either like bypassing it or taking another class or taking it.
So,
How much work?
Well, it's a degrees. Oh, yeah. It was just like part of it was like part of the class meeting. The problems themselves were not. At least I did.
You had to write papers.
Music. Like right off the bat. This poem, you guys. Yeah. Oh, yeah. And I did that. It's too long. I just want to know. Yeah. Because I'm in there. So like
Hi, Megan. Here. Elsa.
here.
Morgan.
Here.
Allison.
She's running late. She'll be here in a few minutes.
Okay, thank you. Katie.
Here.
Leah. Here. Catherine.
Here.
Curtis.
Here.
All right. Any question about home assignments due today?
Can you just talk about that last one, because I felt like I didn't do it right. I'm
Okay.
writing, but I just
All right. Also, I will post the final practice exam under this week. So for students not from this campus, we have to download, print out, or you can just work on a piece of paper. So that is due 2 weeks from today. James, can you get a practice copy? All right, so last problem. Oh, you mean the combination, right? How to figure out N3, N23? Okay. Well, so recall the definition of combination. So what's the definition of N choose R? But the other way to write it is C and R. So remember the definition?
I've been working out like the factorial, like
Yes,
the
yeah.
factorial on the bottom.
Huh? You can do either way. Either way works. So there's a definition we have in the we given out. What was? Does anyone remember? The top is
I've got n factorial
divide by.
divided by n minus r factorial.
Uh-huh.
R factorial.
Yes, that's right. So you can plug everything in there. So in your homework question, n is the same. N is still the same as n, which is unknown. So you have to leave that n in there. But r is given. What's r? 3. So that's all you have to do. Replace the r with 3. So that's all. I mean, there is another way you can do. What's the other way you could do if you know the bottom is 3 or 4? Remember, we also learned this in statistics. The bottom starts from the bottom number. The top starts from the top number. You go down by 1 each time until you go down to 1 on the bottom. By the top, you should match the number from the bottom. So that's the other way. Both will work. So either plug into this definition or do the other way. For example, if I have 5, 3, this is what I do. 3 times 2 times 1, 5 times 4 times 3, right? So even if it's changed to n, you go down by 1 each time, but by n, right? So 5, you go down to get a 4, but n, when you go down by 1, what do you get? N minus 1, and then you go down by another 1. Okay. All right, any other question about the homework due today? Okay. So if not, we're going to look at 6.7. It's called the Binomial Theorem. This is the formula from in algebra class. I'm sorry, 6.7, not 6.7. It's called the binomial formula theorem. Okay, think about a question we did in algebra. Where if I want you to do a plus b to the first, that is just going to be a plus b because first power is like doing nothing. But what is a plus b squared? Yes, okay. So James already memorized the formula. So it's a squared plus 2ab plus b squared. If you have not memorized this formula, you have to do what? A plus b times a plus b. And we did this in our proof question. So a times a squared, and then a times b, and then b times a, and b times b. And a times b and b times a, because there are like terms, so you can combine them to get 2ab or 2ba. Usually we like to follow the order, the alphabetical order, so you get 2ab there. And so that's how you get that. Okay. So anyway, that's the answer. But what would be the answer for a plus b cubed? Has anybody memorized the formula? A cubed plus 3a squared b plus 3ab squared plus b cubed. Well, if you have not memorized the formula, what do we have to do? Yes, you got to do 3 copies. You have to do a times b times a plus b times a plus b times a plus b 3 times. And when you do that, you multiply the first two. You get a squared plus 2ab plus b squared, and then multiply with a plus b. And you got to distribute, and combine like terms. Okay. Well, it gets more and more difficult, tedious. It's not really difficult. You just have to do it more times. So if you have a plus b to the 4th power, then you have to multiply 4 times. Or 5th power, you have to multiply them 5 times, and so on. So we really don't like to do this way, like we did in algebra. There's no quick way. You just have to multiply. So here we're going to give you a theorem that will save you all that trouble. You don't have to multiply. Say if you want to do a plus b 5 times, or a plus b, you can even do a plus b to the 10th time, or 10th power, or 80th power. There's a quick formula that you can follow to get the answer immediately without doing multiply them 10 times. So that's called binomial theorem. The reason they put binomial theorem in this section, in this chapter, is because we've got to use combination, which we learned. And usually in algebra, they don't really teach us this formula because, again, it uses combination. Usually in algebra class, we don't teach combination. So let's take a look at, we can do, say, if I want to do a plus b to the 4th, how do we generalize the formula? Later, you can just memorize the formula, but I want to give you an idea. How did they get that formula? Maybe I can go ahead and write down the formula for you, and then I will explain where they get that formula. So the formula is on page 364. So a plus b to the nth power, so any power, even 10th, 100, you can use this formula, equals, so there are two forms given. One is in summation notation, but we're going to skip that. I'm just going to write down the expanded form. So n choose 1, n choose 2. Plus dot, because there are n of them. We're just going to write down the first 3 terms and last 2 terms. Okay. The formula looks kind of complicated, but once I explain it, it shouldn't be too difficult to memorize. So let's take a look at this example. If I want to do a plus b to the 4th, the idea for others are similar, and it will help us understand how we got this sort of looks complicated formula. So remember, before we have this formula, the only way we can do this question is to multiply this 4 times. I mean, usually in algebra class, I don't think we try to multiply all 4 of them together. So what we try to do is multiply the first 2, get the answer, and multiply the next one, and then multiply the 3rd one. But now we're going to try to multiply all of them together. So try to understand the multiplication. If you want to multiply 4 binomials together, what does it mean? So when you do when we do multiplication, we are trying to pick one from each pair of premises and multiply them. So look, multiplication is right here, and right there, right? So what do we multiply? One of them from here times one of them from each pair of premises. So think about it. How many ways do we have? Can we pick those variables there? Say, for example, the first pair of premises, I can pick A, or I can pick B. The second pair, the same thing. Pick A or B, pick A or B, pick A or B. So, the most number of A's we can pick is what? How many A's can we, the most number of A's we can pick? That would be 4, okay, right? So you can pick A from each pair of premises and multiply them. So I'm going to pick A here, pick A here, pick A there, and pick there. And when I do that, I'm going to get A to the 4th. A times A times A, right? Okay. So the first one, if you look, how did we get A to the n? It's because we pick one A from each pair of premises. You're going to get an n copy of them. So that's how you get A to the n. Okay? Now, well, what about, so the next one, that's the only way to get 4 copies of A to the 4th. Well, next will be, what if I only pick 3 A's? So, well, how do we pick those 3 A's? If you pick, there are 4 A's available. If you only pick 3 A's, that means the other one you're going to have to pick a B, right? Okay? So what will that give us? Out of these 4 A's, and 4 B's. You're going to pick 3 A's and 1 B. And multiply them. What do you get? A cubed times B, right? Because if you pick this A times that A, you get it. A times A times A, and the last one you pick B, you can multiply by B. That will give you A cubed B, right? Okay. So if you look in the formula, where does this come from? A to the n minus 1, because this is the most number of A's you can pick. The next one will be decreased by 1. So you're going to pick n minus 1 copies of A, and there's going to be, you have to pick a B, right? Okay. So this is how we get A third B, or A n minus 1 B. But how many ways to get A third B? When you pick 3 A's, I can pick these 3 A's, and last one I pick a B. But I can pick the first 2 A's and a B and an A. Or I can pick these 2 A's, these 3 A's and that a B. Or I can pick these 3 A's, that a B. So all of these will generate A third B, right? And if you go back to the process of A plus B times A plus B, which is A plus B squared, that's what we did. Look at that, what we did. So we have 2 of them. It's much easier. So you're going to pick A from each pair of parentheses. You get A squared. And then how do you get it? And then reduce A by copies of A by 1. You're going to get it 1A and 1B. So how many ways are there to pick 1A and 1B? You could pick this A, that B, or this A, that B, right? Okay, so that's why 2 ways you can get 2AB. Now, similarly, take a look at here. Because we have 4 of them, it's much more complicated. So the question is, how many ways are there to pick 3 A's and 1 B? You can think of each of the parentheses as a group. So I have this group, 4 groups. And maybe that's an art student. A represents an art student. B represents a biology student. So if I want to pick from out of these 4 groups, I want you to pick 3 art students and 1 biology student. How many ways are there? Pick 3 A's, 1 B. How many ways are there? I gave you a few examples. I can pick these AAAB, or AABA, or ABAA, or BAAA, or others, right? So how many ways do you think we have? We need a formula. Think about what we just learned last Wednesday, combination. It's kind of like you have 4 art students. So this art student, maybe James. This art student, maybe it's Elena. Maybe that art student is Austin. There's another art student, maybe Leah. So there are 4 art students you can pick. How many ways are there to pick 3 of them? 4? Yeah. How did you get 4?
Because the options that you just went through, there were 4 of them.
So you pretty much counted I listed all of them, right? But we don't really want to do that for big numbers. If I do A plus B to the 10, it's gonna be tedious to pick 9 of them, try to count how many, right? So we try to find a formula that we can use later, so I don't have to list all of them. And think about the question combination we did before. If you remember the combination, suppose you have 4 art students, and you want to pick 3 of them. Well, the example I gave you is like doing shifts, say you are the manager, you have 4 employees. You want to choose 3 of them to work on Christmas Eve. How many ways are there? You have 4 employees, and you want to choose 3 of them to work. Choose 3 to work on Christmas Eve. How many ways do you have? Different ways to choose those 3 people. What's the formula? I don't need the answer. I just need you to give me a formula to. Or what do you say? What's that? It's a 4, choose 3. It's pretty much 4. How do we read this? We read it as 4, choose 3. Exactly what the question is. You have 4 people, you choose 3 people, right? So it's 4, choose 3. And if you work this out, it's 4 times 3 times 2, or 3 times 2 times 1, and it's exactly 4. Can you see that's the same type of question here? So you have 4 A's available. You want to choose 3 of them. You want to choose 3 of them. And does the order matter in this case? Does the order, when you switch the order, does it give you a different way or not? No. Yes or no? No, right? So if I have James, Elena, and Austin, and maybe Curtis, and then when you say James, Elena, Austin, it's going to be the same as Elena, James, Austin. The same as Austin, James, Elena, and Austin, Elena, James. It's the same 3 people working on the Christmas Eve, right? So when you change the order, it doesn't make. When you change the order, if it doesn't make a new way, a different way, we say the order does not matter. If the order does not matter, then it's going to be combination. Okay, so how do you remember a combination? Try to use the example to help you. What's a combination? So maybe we should go over that, the difference between permutation and combination. In combination, the order does not matter. Order does not matter. But in permutation, the order, give you example like scheduling shifts. So if you have morning, afternoon, evening shifts, that would be it. Say James in the morning, Elena in the afternoon, Austin in the evening. It would be different from Elena in the morning, James in the afternoon, and Austin in the evening. So that would be considered different if there is an order, if you have 3 shifts. But if you don't have 3 shifts, all 3 of them are going to work on the same day. When you change them, it doesn't make a difference. So if I say, hey, James, Austin, Elena, you guys got to work tomorrow. But I may call the names in a different order. Elena, James, Austin, you're going to work tomorrow. Well, 3 same people will show up, right? There's no difference, right? But if I say, okay, James, you work in the morning, Elena, you work in the afternoon, and Austin, you work in the evening, that would be different from saying, Elena, you work in the morning, James, afternoon, Austin, evening. That would be a different scheduling, right? Okay, so make sure you pay attention to the difference between permutation and combination. So combination is, the order does not matter, so 4 choose 3. So the same thing here. When you choose, say, for example, I want to choose these 3 A's and that B, it doesn't matter if you choose this A and this A, that A, or I can say this A, that A. That's the same 3 A's, right? So you're going to get an A times A times A. It doesn't matter which one you choose first. So over here, how many ways to choose 3 A's? It's going to be 4 choose 3. So you do 4 choose 3, which gives you 4. So you're going to get 4 copies of A cubed plus B, which is 4A cubed B. Okay, does that make sense? So how many different multiplications will give you A cubed B? Yes, you can do it. Say I can do A times A times A times B. That's A cubed B. Plus A times B times A times A. That's still A cubed B. And I can do A times B times B times A. Excuse me. If you list all the 4 different ways, maybe I can show you. So I could do that. That's one way. I could do A, B, A, A. That's another way. I can do maybe B, A, A, A. I have another way. So I did not choose B here, did not choose B here, did not choose B here. So the only one left if I could do A, A. Okay. So look at these 4 different ways. If I list all of them, this is what we are doing. said, this is really tedious, right? You don't want to do this, especially for a big power, big exponent. So, but in either way, look, a times a times a times b, that will give us a cubed b. A times b times a times b, still gonna give you a cubed b, right? Although in a different order. So then you do b times a times a times a, so you get a ba cubed, but ba cubed is the same as ab cubed, a cubed b. And a times b times a is still gonna be a cubed b. So you're gonna have all together, if you add them, you're gonna get a 4a cubed b. But the important thing is, where does that 4 come from? Do I have to do this every single time? I don't want to do this every single time. So if you look at how we did this, it's like choosing 3 A's from 4 of them. So how many ways are there to choose 3 A's from 4 A's? Well, it's 4 choose 3. So you don't have to do listing anymore. That 4 can be easily generated by using this formula, 4 choose 3. Okay, so think about how we get this. I got 4 A's. I want to choose 3 A's. There's 4 choose 3, that many ways to generate a cubed times b. So go back to look at our binomial theorem. Look, how did they get n choose 1? Well, I guess they didn't really focus on a, they focused on b. So how many ways are there to choose 1b? There's n b's available, you choose 1b. So the other way to do it, you can also do that. Say, okay, how many ways are there to choose 1b? If you choose 1b, it's going to be the same as choose what? 3 A's, right? How many? If you after you choose this b, the other has to be 3 A's. Well, if you choose these 3 A's, the last one has to be. So it's going to be the same. So what the textbook did is this: 4 choose 1 instead of 4 choose 3. But 4 choose 1 is the same as 4 choose 3. So if you work it out, see what we get here. 4 choose 3, I can also do 4 choose 1. 4 on the top, 1 on the bottom. See, it's still the same. And by looking at the example, you can tell why 4 choose 3 is the same as 4 choose 1, because how many ways to choose 3 is going to be the same as how many ways to choose B. To choose 3 A's. Once you choose these 3 A's, the last one has to be. Once you choose this as your B, the other 3 has to be A. So that's why you can do either way. So similarly, in the next one, what do we do? Let me put a plus sign there for them. So it's going to be plus right here. Now, next we're going to, so if we pick 4 A's to multiply. Now, we pick 3 A's to multiply. What will be the next one? Following the pattern. Yes, A squared, B squared. So you're going to choose 2 A's. If you choose 2 A's, how many B's will there be? 2 B's, right? If you choose 2 A's, the other 2 you cannot choose A's anymore. They have to be 2 B's. But how many ways are there to choose 2 B's? How many ways are there to choose 2 B's? How many B's do we have?
2.
Wait, available. How many B's are available? 4 of them. You want to choose 2 of them. You can only choose 2 of them. So
4 over 2.
4, don't say over, it's not division. So it's 4 choose 2. Okay. 4, be careful, 4 choose 2 and 4 over 2 is not the same thing. 4 over 2, you're just going to get 2. But 4 choose 2, what do you get for 4 choose 2? You have to do 4 times 3 on the top, 2 times 1 on the bottom. You're going to get 6. Okay, so there's not a line between them. Although it looks like a division, it's not really. I mean, we will do division later, but it's not dividing these 2 numbers. You're going to have to divide more numbers. So that's going to be 4 choose 2 in front of it. So that will save you time of trying to figure out which 2 B's you're going to choose. Say, okay, choose these 2 B's, or these 2 B's, or these 2 B's, or those 2 B's. So there, you don't have to do that anymore. It's going to be 4 choose 2. Now, what is going to be the next term? Choose 1A. If we choose 1A, how many B's do we have to choose? 3 B's, right? So you're going to have, if you choose 1A and 3 B's to multiply, you're going to have A times B times B times B. That's going to be AB cubed. And again, how many ways to choose 3 B's? How many ways are there to choose 3 B's? Give me the formula.
4 choose 3.
Yes, very good. 4 choose 3. And the last one will be what? Choose no A's at all. If you don't choose A's at all, then you're going to have to choose how many B's? 4 B's, which gives you B to the 4th. Okay, so the last one will be 4 B's to choose 4 B's. That will be 4 choose 4. Well, if you know what's 4, if you do calculation, what will you get if you do 4 choose 4?
1.
Has to be 1, right? Because you choose all of them. There's only one way to choose all of them. So that last one, if you don't want to use 4 choose 4, you want to use like 1, that's fine. And in fact, the first one, to be consistent, if you try to find a formula, to be consistent, you can put a 4 choose 0 there. Because you don't choose any B's, right? So it's like B to the 0. B to the 0, so 4 choose 0. The same thing here, I can say A to the 0. But by the way, what is A to 0 and B to 0 equal to?
1.
They're both equal to 1, okay? So that's why B to 0 here, you can omit that. A to 0, you can omit that. And also, what is 4 choose 0 equal to? When you have 4 A's, you're not going to choose any of them. 1, yes, that would not 0. You consider that's something you got to memorize. It's definition. So if you have 4 student employees available, you decide that you're not going to choose anybody. That will also be considered as one way of selection. Okay, selecting nobody is also a one way. Okay, so 4 choose 0 will be 1 here. So 4 choose 4 is also 1. So that's why we have that formula given in the textbook without a number, anything in front of A to N or B to N, because this one will be N choose 0. That would be 1. The last one be N choose N. That will also be 1. So they went ahead and got rid of them. But if you want to put them there to be consistent, it will be easier for us to memorize the formula. So take a look at the pattern here. Now, it's always something choose something. What choose what? The exponent. Choose 0, 1, 2, 3, 4. Okay. Why? Because you got to multiply 4 copies of A plus B. And you're going to have to decide how many copies of A you're going to choose. Well, it could be, so you have 4 B's available. You have 4 B's available. You choose none of them, which means 4 choose 0. You choose 1 of them. You choose 2 of them. You choose 3 of them. You choose 4 of them. So that's how you get 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And once you write that down, you can determine A's and B's. In the first case, because I choose, let me write it down here. So the first one, what did I choose? I choose 0 B's. I choose 0 B. If I choose 0 B, that means I have to have 4 A's, right? 4 A's. Now this one means I choose 1 B. If I choose 1 B, that means I have to have 3 A, because altogether you have 4 princes. You must choose something, either A or B, from one of them. If you have 4 of them and only choose 1 B, that means the other 3 pair of princes you have to choose A. So that's why you get A third. And the same thing here. If you choose 2 B's, you're going to have 2 A's, 3 B's, 1 A, or 4 B's, no A's at all. So that's how you memorize the formula. So following this pattern, suppose I want to do A plus B to the 5th. I don't have to do 5 copies anymore. Let's do like A plus B to the 5th by using the formula. So think about it. You can either focus on A or focus on B. It doesn't matter. So I'm going to follow the textbook and focus on B. So let's see. We have 5 copies of B's available. And we choose 0 of them. Choose none of them. Okay, so 0 B's. So this will be, we're going to choose 0 B's, 1 B, 2 B's, and 3 B's, and 4 B's, and at most 5 B's available. But you only have 5 copies, right? So now you have to do, let's do 0 B's, which means 5 choose 0. If I choose 0 B, what I'm going to get for the variables A and B's? Well, choose So if I choose no b's at all, 0b means no b's. If I don't choose b's, which means what do I choose to multiply?
A.
A's. How many a's?
A to the fifth.
Yes, a to the fifth. Okay. I can write this here down as your for your reference, but when you really do the question later, you don't need this anymore. So you're supposed to multiply 5 copies of them, but you're going to keep a certain order. So focus on B. So first, I'm not going to choose B's at all. For each pair of parentheses, I'm going to choose A, and you multiply them. You get A times A times A times A times A. You're going to get A to the fifth. B to the 0. B to the 0 can be omitted because B to the 0 is pretty much equal to 1. And this 5 to the 0 can be omitted because 5 to the 0 is also equal to 1. So if you just want to write out A to the fifth, that would be fine. Now, can you tell me what the next term will be? 1b. Choose 1b, which means 4 A's. So what will this be next term?
Choose 1
Mm-hmm.
times
Time.
A to the fourth
Uh-huh.
times B.
Times b. Very good. All right. Does everybody understand how we got this? So we're going to choose 1b. If you're going to choose 1b, there are 5 b's available. Look, we have 1, 2, 3, 4, 5 b's available. How many ways are there to choose 1b? 5 ways, right? So you can either choose this b, or this b, or that b, or that b, or that b. But there we have a formula. 5 choose 1. So 5 b's choose 1b. There's going to be 5 choose 1, that many ways. And if you choose 5 b's, you have to choose 4 a's, because together there are 5 copies available. You must choose something from each pair of parentheses. Okay, notice the pattern is when you add the exponents of a and b, what do you always get? When you add the exponents of a and b, what do you get?
5.
4 from 5, right? It has to be 5. Why? Because you have to choose either A or B from each one of them. You must choose one from one of them. So if you choose 4 A's, there's one pair of parentheses that you have to choose a B. So together it should always be 5. Now, what's the next term?
5 choose 2
Yes.
times A to the third, or to 3 and B squared.
Yes. Okay. So you increase the number of B's by decreasing the number of A's. All right. Next one will be 2 A's, 3 B's. So that would be 5 choose 3, A squared, B cubed. And next one will be 5 choose 4, 1A and 4 B's. And last one will be 5 choose 5. And no A's, I can put A to the 0 and B to the fifth. Or you can omit that. We do have to continue to simplify that. In previous example, I did not simplify that, but if we simplify that, 5 choose 0, it's 1. B to the 0, it's 1, so we get A to the fifth. 5 choose 1, work it out, it's 5. A to the fourth B. Plus 5 choose 2, you can do that on your scratch paper. 5 choose 2, it's 5 times 4, 2 times 1, so it's going to be 10. 10, A third. And you can work the other one out. That should also be 10 there. And that should be a 5 there. And a 1. So that would be the final answer for A plus B to the fifth. Okay. So this will save you time of multiplying A plus B 5 times. You can just get the answer. All right? Okay, notice in the formula we use combination. Any question? Yes. I'm sorry? Wait, you mean 1, 5, 10, 10, 5, 1?
Yeah.
Yes. What about them?
Always thinking that way, like the other one.
Oh, you mean like kind of like symmetric?
Yeah.
Yes. There is Pascal's triangle. Pascal's triangle. I don't know if anybody heard of that. Okay. the numbers. So James noticed the numbers in front of them. Let me go ahead and put down the answer in all of those. You see, there's kind of a pattern there. So a plus b to the fourth, which is what we did before. Let me write down the answer here for a plus b to the fourth. So it's going to be a to the fourth plus 4a third b plus 4 choose 2 is going to be 6. A squared b squared plus 4ab cubed plus b to the fourth. And then I'm going to copy the answer for fifth power down here. I put them all of them together so you can see there's a pattern of the numbers, about the numbers in front of the variables. We call them coefficients. 5ab fourth plus a fifth. Okay, so look at the numbers in front of them. The first one is 1, 1, right? Okay. The second one is 1, 2, 1. The third one is 1, 3, 3, 1. The fourth one is 1, 4, 6, 4, 1. And the next one, fifth power is 1, 5, 10, 10, 5, 1. Those numbers will form a perfect triangle, which is called a Pascal triangle. So this might give you an even quicker way to do this. Let me put the numbers down here. The first one is 1, 1. Second one is 1, 2, 1. So then when we put it, we're going to sort of do this. Okay, so it's like 1, 2, 1. And the next for the third power is 1, 3, 3, 1. And look, the numbers, you always have 1 at the beginning and 1 at the end. But the number in the middle, it's kind of like you add the previous two ones, you get that. So how do you get 3? You add these two, you add these two. How do you get 4? You add these two. How do you get 6? You get these two. So how do you write this down? So that's a plus b to the first. A plus b to the second. The numbers in front of them is 1, 2, 1. So this 2 is generated by adding those 2 ones. And a plus b to the third, you're going to get a 1. You always put on 1, shift it to the left a little bit. And how do you get next number? You add these 2, you get 3. You add these 2, you get another 3. And then you add another 1. So look, 1, 3, 3, 1, right? So we're going to, how do you get the numbers in front of variables for the fourth power? You add a 1, and you add these 2, you get a 4. You add these 2, you get a 6. You add these 2, you get a 4. And you add another 1 down there. And look, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay? And so similarly, a plus b to the fifth, you get 1 here. Add these 2, get 5. Add these 2, get 10. Add these 2, get 10. Add these 2, get 5. And you get a 1. So if I want to generate the numbers in front of 6 power, what will they be? You have a 1, 6, 15, 20, 25, 6, and 1. So
That would be 15, right?
Oh, 15 here. So that would be even faster. So if you want to write down what's the answer for a plus b to the 6th power, you don't even have to do like 6 choose 0, 6 choose 1, 6 choose 2 if you have this triangle available. So you're going to get the a to the 6th, that's the number in front of a to the 6th, and the number in front of a to the 5th, the number in front of a to the 4th, the number in front of a to the 3rd, and the number in front of a to the 4th, and 5th, and last one is a to the 6th. Well, it's much quicker, right? So pretty much you can write down. But what if I ask you to do a plus b to the 10th? Well, you still have to keep generating this triangle so you can get numbers, right? Or you could just use our formula, 10 choose 0, times something, plus 10 choose 1, plus 10 choose 2. So with the triangle, it's easier. You just have to put numbers in front of them, but you can have to keep generating until you get 10th row, so you can get numbers in front of it. Okay. All right. Any other question? Okay, so this is sort of like an application of combinations, and that's a formula in algebra we sometimes use. Now, well, most of the questions you're going to get may not be exactly a plus b to the 6. What if I have a minus b to the 6? Or maybe I have like 3a minus 2b to the 6. Well, what do we do if you have something like that? So let's try to do maybe an example from the textbook on page 367. Ax minus 4y to the 4th. So how do we do this? So this is, we know how to do a plus b to the 4th. If it's a plus b to the 4th, we know 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and then you a to the 4th and 3rd and 4th and so on. So in this case, if you have something other than just the variable ab, you may have a number, you may have a negative in front of it, you will consider x as your a, negative 4y as your b. So this can be written as x plus negative 4y to the 4th. It's kind of like doing a plus b to the 4th, right? But when you plug in that a and b in there, you cannot really use b anymore. It's like x and negative 4y. So let's see how we get this. Now, the formula will still be the same. So 4 choose 0 times, I'm going to choose 4 copies of a, which is x. But I'm going to choose 0 copy of y. 0 copy of y. No, I'm sorry, not y. So 0 copy of b, but it's not really b, it's negative 4y. Okay. Now, next step, we're going to choose 4 choose 1. And choose 3 copies of a, but that's our, a is like x here. And times 1 copy of b, which is negative 4y. And now we choose 2 copies of b, which means 2 copies of a, that's x, and times negative 4y second. And plus 4 choose 3. So we're going to do 3 copies of b, which means 1 copy of a, and do 3 copies of b. And again, b is negative 4y. And last turn is 4 choose 4. No x, but I can put x to 0 to be consistent, and negative 4y to the 4th. Okay, if you take a look, compare this to the one we just did before, a plus b to the 4th. If you compare that, see, it's the same. 4 choose 0, 4 choose 0. Something to the 4th, something to the 0, plus 4 choose 1, something to the 3rd, something to the 1st. The pattern is going to be the same, but we have a here, but in our example, it's not a, it's x. So every time you see a, you're going to use x to replace it. And again, every time you see a b, it's this whole thing here, negative 4y. So that's like our b, b, and b, and b. So b to the 0, choose no b, choose 1b, choose 2b's, choose 3b's, and choose 4b's. And a is very easy, it's just our x. But the x I could also make it like 2x or something there. Well, you would have to replace x with 2x, 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 2x. So let's simplify this. 4 choose 0 is equal to 1. X to the 4th is x to the 4th. What is negative 4y to 0? What's that? Anything raised to 0 is equal to 1. Yes, that's right. So remember that. It's going to be 1. So you don't have to put it there anymore because anything times 1 will be the solve. 4 choose 1 will be 4. X third will be x third. Times negative 4y. You still have to continue to multiply that out, okay? If you want to do everything in one step, you can. But I'm going to slow down and do one more step after this. 4 choose 2 is 6. X squared, negative 4y squared. Okay, what do we get? Negative 4y squared. 2 copies of negative 4y. 16y squared. So you do negative 4 squared, which is 16, positive 16. Y squared is y squared. 4 choose 3, it's going to be 4 and x. And third power, negative 4 times negative 4 times negative 4. Negative 64, y third. And next step is, last step is plus 1 times x to the 0 is 1. So that's 1, that's 1. All we have left is that fourth power. 16 times 16, 256 y to the fourth. So we need to do one more step to simplify this. We get x fourth. Its multiplication here. Positive 4 times negative 4. Negative 16. X third times y. This is going to be x third y. The next step, positive 6 times positive 16. 96. X squared times y squared. And next one will be negative 64 times positive 4. Negative 256 x y third. And plus this one more time, 256 y. Okay. And by the way, the numbers this time won't be the same as the triangle anymore, Pascal's triangle anymore, because you got to take this negative 4 into consideration. Those 1, 4, 6, 4, 1 do follow that operation, the Pascal triangle. Because B also has a negative 4 in there. So when you do the powers of negative 4, you're going to change those numbers. You're going to get different numbers. Okay. All right. Maybe I'll do one more example like that. So we may have like a square in the question. We may have x squared minus 2y to the, let's just do the third. All right, so use the formula to do it. Instead of, multiplying 3 times, so we do, which one will be A? A will be your x squared, and B will be, what's B? Negative 2y, yes. So that's your A, that's your B. All right, by the formula, so we do 3, choose 0, and 0 copy of B. Let me mark it, that's A, that's B. 3, no copy of B, which means 3 copies of A. But what is A? A is x squared. So you're going to write down x squared to do another 3 copies. So x squared to the third. And for B, it's 0. And so like those ones, if you want to omit them, you say don't want to write them, it's fine, because that would be 1 anyway. Then we do 3, choose 1. And this time we're going to reduce the number of copies of A by 1. So we do squared. But the number of B's will have increased by 1 to the first. And plus 3, choose 2, x squared to the first. Negative 2y to the second. You always increase one of them by 1, decrease the other one by 1. We choose 3, x squared to 0, and negative 2y to the third. Any question about this? Okay. All right, so again, trying to think of this as your A, and this whole thing as your B. So this is like A, this is like B, A, and B, A, and B. Okay. So we're going to get 3 to 0 to 1. So you're going to get x squared to the third. What's x squared to the third? 6 multiply exponent. 2 times 3 is 6. And that one is just going to be 1. Plus 3 over here, x squared squared. That's going to be x to the fourth times I plus another 3x squared. Negative 2y squared would be 4y squared plus 1 times 1 times negative 8y to the third. But you do negative 2 to the third, negative 8, y to the third, y to the third. Simplify one more step. Positive 3 times negative 2. Negative 6. Positive 3 times positive 4. Positive 12. And minus 8y cubed. All right. So that's how you use the binomial theorem to algebra question. Okay, questions? So it's about 20 minutes. The next, I think I'm going to talk. So I'm going to talk about one. We finished chapter 6, and now we're gonna look at chapter 10, relations. So we're skipping 8, 7, and 8 and 9. Chapter 7 is talking about functions, which you learn a lot in algebra and calculus. I mean, we do talk about something a little bit new, but we're going to skip that. And chapter 8 is talking about recursive definition, and we are also going to skip that. Chapter 9 is for computer science majors, so we're going to move on to chapter 10. It's called relations. Relations on sets. But in real life, we have all kinds of relations. Say, sometimes you may say, I am related to him. But usually when you say that, probably you mean by blood or because he is a relative of yours. Here, the relation is going to be defined any way we like. So it's sort of similar to the relation we say in real life, but it's more generalized. So I could define the relation any way I want. So if I say, I'm related to Elena because I am her professor. So the way I'm defining this relation, when I say related, I don't mean we are related by blood because I am her professor. So you can define any way you like. Or I can define by age. Say, I am older than Elena. If I am older than Elena, I say Elena, I will say I am related to her. So you can define any way you like. Or maybe I can say James is related to Elena because James has the same major as Elena. So the definition here, relation, is usually given, and they have to tell you how they define the relation. Okay, so let's look at some examples of that. Okay, let's see. So this is an example from the textbook. We have two sets, A and B. So usually when we talk about relations, you have two people or two numbers, or two something, two triangles, or two of anything. But you do have to define where they come from. So, for example, I will say the first number will come from A and the second number will come from B. So recall one of the definitions we learned before. This is like a side note. Maybe I can just put it. Maybe you don't have to put it here. Later we will talk about this. So for now, you don't have to write this down. So think about what we did on the second exam. There was a question asking for the product of two sets. So do you remember how the product is defined on two sets? Huh? You're going to form points. And 4 points. So the first point will be 0, 1. The first component, what you can call it x coordinate, comes from A. The order does matter here. So if they put A first, you have to start with A first. 0 comes, the first component always comes from A. So you can have 0, 1. Pick 0 from A, pick 1 from B. And you can pick 0, 2. You can get 0, 3. And you can also do 1, 1, 1, 1, and 1, 2, and 1, 3. 1, 2, and 1, 3. You can also start with 2 to do 2, 1, 2, 2, 2, 3. That is called 2, 1, 2, 2, and 2, 3. So that's called Cartesian product. It's like points. We have, we got 3 times 3, 9 points. That's all the possible relations you could get, related pairs you could get. So later, in this case, in this chapter, we're not going to consider it as a point anymore. We're going to consider it as like 0 is related to 1. So for example, when we get 0, 1, we say 0 is related to 1. But when you have 1, let's say we look at a different one. 1 and 2, 1. So 1, 2 means 1 is related to 2. And 2, 1 means 2 is related to 1. So all the relations in real life can be described mathematically as a product of sets. Well, I use the numbers, but they don't really have to be numbers. What if, say, 0 means James? That's his number. And then 1 means Elena. 2 means Austin. And so what does this mean then? So 1 means Elena, 2 means Austin, maybe 3 means Curtis. And then 0, 1 means James is related to Elena. And 0, 2 means James is related to Austin. 0, 3 means James is related to Curtis. So they don't have to be numbers. They could be people. So that can be used to describe the relation in real life. So you can sort of like set up a model for the relations in real life mathematically. So it's sort of like math modeling. And okay, so next question. And again, I listed all the possible relations. But maybe James is not related to Elena. And then you won't have that in there. Maybe James is not related to Austin. Then you won't have 0, 2 in there. So it depends on how do we know which one is in there. These are the all possible related pairs. I listed all of them, all possible related pairs. But in real life or in certain situations, depending on the situation, you may not have all of them. You could just have 1 of them or 2 of them, or maybe you have all of them. So how many do you have? Well, which ones will you have depends on the relation that is defined. So here I'm going to define a relation here. This is how we define it. We say x is related to y. X comes from A, y from B. So x is from A, y is from B. An element from A and element from B. When we say x is related to y, if and only if x is less than y. That's how I define it. But that's not the only way. You can, like the examples I gave you, you could define it anyway. I can define x is greater than y, or x plus y is equal to 0, or something else. Okay, so let's follow this definition. I'm going to call this relation R. Usually we use a capital letter to represent the relation, to make it easier for us to write. Because I don't want to write this long sentence every single time. Say x is related to y, x is related to y. It's a lot of writing. So later, if I call this relation R, how do I write x related to y? I just need to put an x, R, y. I don't have to write a lot of words anymore. So this R means that relation defined. So now let's see. Check every possible one there. Is 0 related to 1 in this case? Yes or no? Yes, right? Why is 0 related to 1? Because 0 is less than 1. It follows the definition. It meets the definition. The first number, 0 is less than the second number, 1. Then you say 0 is related to 1. Now, is 0 related to 2? The second possible pair is 0. Yeah. So this should be in there. Yes, because 0 is less than 2. Similarly, 0 is also less than 3. So we checked the first 3. They all work. Now, what about the next one? 1 related to 1. Is 1 related to 1? No. So you can put a line kind of through that. Say 1 is not related to 1 since 1 is not less than 1. So this means not related to. The next one is 1 and 2. 1 is related to since 1 is smaller than 2. And then 1 is related to 3 since 1 is less than 3. So I'm checking every single one. This one does not work. This one works. 2, 1, 2, 2 will not work, right? Because 2 is not less than 1. 2 is not less than 2. So 2 is not related to 1 since 2 is not less than 1. And 2 is not related to 2 since 2 is not less than 2. And last one, 2 is related to 3 since 2 is less than 3. So we found out all the ones will be in this relation. So we can list all of them here. So what pairs will be in this relation? I already kind of marked here, so you can copy down what we have. This R right here can be described, a relation can be described in order of pairs now. It's kind of, we have 0, 1, 0, 2, 0, 3, but not 1, 1. So we have 1, 2, 1, 3, and 2, 3. That's it. So that's all the related numbers for this relation. Now, next I'm going to change this. Change the relation. Let's call it, let's define this relation as, maybe, I'm going to use a different name. Let's call it L. The relation L is defined as x is related to y. So this L means related to. L is related to y if and only if x minus y is even. Okay. So let's see which ones will, out of these all possible 9 pairs, which ones will be in this relation, will meet this relation. Let's do it again. Is 0 related to 1? What do I check now? We're not comparing if the first is smaller than the second anymore. We're checking x means the first. The first number minus the second number is even. If it is even, we say they're related. If not, we say they're not related. So in this case, what do we get? 0 minus 1 is negative 1. It's not even, right? So you say 0 is not related to 1 since 0 minus 1 is not even. What about 0, 2? Yes, right? Since 0 minus 2 is even. Now 0 is not related to 3 since 0 minus 3 is not even. Okay, next one is 1, 1. Is 1 related to 1? Yes or no? Yes, right? Because 1 minus 1 is 0. Well, 0 is even. So 1 is related to 1. So I did 1, 1. Next is 1, 2. And 1, 3. So 1 is not related to 2 since 1 minus 2 is not even. Well, to make it easier, I think you get the idea how to do this. I'm just going to write down which ones are related, which ones are not related. So 1 is not is related to 3 because 1 minus 3 is negative 2, which is even. Now we're done with 1, so it's 2, 1, 2, 2, 2, 3. 2, 1, 2 is not related to 1, but 2 is related to 2. And 2 is not related to 3. So for this relation L, which ones will be in there? We have 0, 2, we have 1, 1, we have 1, 3, we have 2, 2, and that's it. So as you can see, when you change the definition, well, which ones will be related will be different. So that's the one we got. If we use the less than relation, these are the ones we got. If we use x minus y is even, then these are the ones. These are the pairs that are related. Okay, and the next question. You should be able to do. So that should these examples should help you do your homework. Number 2, they just have you different numbers: 2, 3, 4, 5, and 3, 4. So they want you to check. They didn't ask you to check every single one. They just asked you specific ones. For example, is 2 related to 4? Because they use the S to describe the relation. By the way, the binary means 2. You can talk about 3 people, 3 numbers, whether they're related. But for lower level math, we don't. We just talk about 2. That's why we call it binary relation. So there's a different way to write it, besides the way we just used. The other way to write them related, I did already give you that. So if you look at what we have. So of course, for 0 related to 1, you could write it as 0 related to 1, using whatever the letter they use for the relation. But you could also write this way, by order pair. So that also means related to 1. There are 2 different ways to write. It's in the relation. Because if you look at the set, the relation R, 0, 1 is in there. So 0, 1 is in that relation. Okay, which means 0 is related to 1. So like I said, we are changing the way we say in real life, changing a relation to an ordered pair. So when you look at 0, 1, it just means really 0 is related to 1. Like these 2 questions just ask, what does this mean? Is 4 related to 4? Is 3 related to 2? So the same thing. Part B, write S as a set of ordered pair, which pretty much is the one. That's the one you have to do. For part B, you have to check every ordered pair. You got to check 2, 3, 2, 4, and 3, 3, 3, 4, and 4, 3, 4, 4, 5, 3, 5, 4. Found out all the related pairs, just like what I did in that example. So I listed all the possible ones, and then I plug each one in there in the relation to check which ones will satisfy the relation, and write down all of them in the set. So That's relation R, that's relation L. Okay, so that's the first question. First two should be the same. Actually, first three. So that should help you do number 2, number 7, and number 8. Number 8, just take a quick look. I think number 7, you should understand how this is defined. X, Y, X is the first, Y is the second. When pay attention to the order does matter. It's the second number, Y, is equal to the first number squared. Okay, so let me give you an example. This is the definition. X is related to Y. They could have put it this way, or they could have put it this way. X is related to Y. This is how they define it. Let me give you a case. You can tell me whether they're related. So is 4 related to maybe 2? Is 4 related to 2? Yes or no? So it seems like, well, yes. It seems like yes, right? Because it seems like, well, 2 squared is equal to 4. But no, because the order matters. Notice that the first, look at the way they put. X is the first number. Y is the second. You cannot switch them. So X is the first. This is the first number, X. This is the second, Y. So when you plug it in, it says the second number is the first number squared. So sometimes when you do the questions, it might be better to replace X and Y with the first and second, because when you look at the X and Y, you might get confused. So it's like saying X is the first, right? The first number squared is equal to the second. Now check. What's the first? It's 4. Second is 2. So is the second number 2 equal to the first number squared? No, right? So they are not related. So 4 is not related to 2. But after I switch them, is 2 related to 4? Is 2 related to 4? That would be yes, right? Okay. So make sure you pay attention to the order. Number 8. How is this relation defined? When M and N have a common prime factor. Common prime factor. Let's write this down. X is related to Y. If and only if X and Y have, the homework uses the M and N, but the variables really don't matter. Have a common prime factor. So if I ask you, is 2 related to 4? Again, well, maybe, sorry, that's fine. Is 2 related to 4? By checking this relation, 2, X is 2, Y is 4. So does 2 and 4 have a common prime factor? Yes, because they do have 2 in common, right? 2 goes into 2. 2 goes into 4. So they have a common prime factor 2, because 2 is prime. So you would say yes. But, next question. Is 4 related to 8? Will still be yes, because 2 still goes in both of them. I guess which way? What about is 4 and 5? Is 4 related to 5? No. No. Because the only number that would go into 4 and 5 would be 1, and 1 is not prime. So you have to have a prime factor, right? So you would say no. Okay? That's how you check how to do number 8.
I have a question about homework.
Yes.
On Blackboard, it says that we have 6.4 and 6.6 due on Wednesday. I just want to make sure that that's correct.
Oh, yeah. Yes, it's due. You mean, are you talking about the due date?
Yeah.
Okay. Yeah, it's due Wednesday. Because I thought some of you might have trouble doing some of the questions, so I was going to give you a few more days to turn it in. But if you finish it and you don't have any trouble, you want to turn it in early, it's fine. So I guess I forgot that. Yeah. Okay. Other questions? All right, we can stop here today. This one actually, and the time, so I have 2 more classes.
Your meeting has ended.